in this video, we're going to be looking at the properties of logarithms. What are the properties, how are they used, and how can we simplify log expressions to solve log equations? So you'll see that in this section, you'll have to do something called expanding logs and condensing logs. If you are asked to expand, that means you are going to take one log expression and change it to several log expressions. If you're asked to condense, that's where you'll take several log expressions and you'll condense it into one log expression. So here are the properties of logarithms we are going to be using today. Take a minute and get these log properties down. So if I were you, I would highlight them, copy them down, screenshot them, whatever you need to do in order to see that, hey, these are pretty important and I need to remember them. So the first one is called the product property of logarithms, and that says if you have the log of two terms being multiplied, you can separate those into a sum of two logs. So if I have a log of 3x, I can separate that into the log of 3 plus the log of x. The second property is dealing with the log of a quotient. So if you have a log of a quotient, you can change it into two logs or expand it into two logs by saying the log of one minus the log of the other. So if I had the log of x over y, I can expand that by saying that is the log of x minus the log of y. The one thing you do have to keep in mind, though, when you're working on these is that the logs that you expand or condense them into need to have the same base. So make sure that you have the same base whenever you divide the logs into multiple expressions. The third property is called the power property of logarithms. That's where if I have the log of something raised to a power, you can pull this exponent right here, pull that exponent down into the front. So let's say I had the log base 7 of x to the third. That's equivalent to 3 times log base 7 of x. Now, whenever you apply these properties, sometimes it will require the use of a variety of properties. You might have to use one of the properties above, two of the properties, or all three. So make sure you look at the whole expression first to determine the sequence of properties that will be used. So we're going to skip part A. We'll come right back to it. Let's start with part B because there's less going on in part B. So part B has got one log, and then the directions say to use the properties to expand. That means I need to change this into multiple logs. Well, I notice I see natural log, and these properties not only apply to the common log, but they also apply to natural log. So I see the natural log of 7 over 225. I can use that second log property. Let me change the color, make it a little darker here. I can say this is equal to the natural log ln of 7 minus the natural log of 225. And I'll be done there. The next one, I see log base 7 of r cubed times t to the fourth over v. And I see, okay, well, there's a power, there's a product, and there's a quotient. So this one's going to require me to use all three properties. So let's just use a few at a time. So this is going to be equal to the log base 7 of r cubed. Now r cubed is being multiplied by t to the fourth, so plus log base 7 of t to the fourth. And then the v is being divided, so minus log base 7 of v. Then I notice that there are exponents. Those exponents can come down to the front. So 3 times log base 7 of r plus 4 times log base 7 of t minus log base 7 of v. And you'll know that you have expanded completely when all of the exponents on your terms that you're taking the log of are 1. And let's see, and there's no coefficients in front of those variables. Now, here's an extra example. Log base 5 of a squared times log base 5 of b to the 7th. I see a product, which tells me I can apply the sum property, or the product property, log base 5 of a squared plus, because these two are being multiplied, log base 5 of b to the 7th. Then pull each exponent to the front. So log base 5, 2 times log base 5 of a plus 7 log base 5 of b. Sometimes, here's another, I'm making up this example. Sometimes you'll have something like log base 3 of 3x. So if I expand that, I can say that is log base 3 of 3 plus log base 3 of x. And you'll be like, oh, each one has an exponent of 1. There's no coefficients. I'm done. However, anytime you have a log of a number, double check to see if you can evaluate this. Can I figure out, oh, that's too light. Can I figure out what log base 3 of 3 is? Well, 3 to what power gives me 3? 1. So this whole part right here is 1. So 1 plus log base 3 of x. So if you have the log with a base of a number, see if you can evaluate it. And that's how you would simplify as much as possible. Then there's times where you have to condense or write it as a single logarithm. So you'll put everything together. Now I recommend looking at the numbers in front and changing those to exponents first. So I'll move that 5 and 7 as an exponent. So now I have log base 2 of c to the 5th minus log base 2 of n to the 7th. And then I notice, hey, look, they have the same base. So they can be combined to log base 2 of c to the 5th over n to the 7th. Here, that 2, I can write as an exponent of 7. Natural log of 7 squared plus the natural log of 2. It's a sum, so this is equal to the natural log of 7 squared times 2. Oh, and I need to write that 2 so it doesn't look like an exponent. Sometimes you'll see that they leave the expression like this whenever they ask for an answer. Other times they want you to multiply it out, to just go with whatever is expected. So 7 squared times 2 is 98. This is the same as natural log of 98. Then if we look down to example 5, you'll have something called the change of base formula. And let me write down the change of base formula. The change of base formula is used to change something that has a base of a number other than e or 10 and writes it so that you can use one of the common logarithms. So, and I'll talk about what that means in a second, but what the change of base does is it allows us to use one of our common logs. So either log base 10 or the natural log. Now, log base 10 and natural log are included on all the scientific calculators. So if you look at your phone won't do a log base. It will do a log 10, the basic calculator on the phone. It just has the log button or just the natural log button. It used to be that calculators did not have a log function that would allow you to change the base, so you would have to use only the common logs, log base 10 or natural log. So this is what the change of base formula would allow you to do. You also need to be aware that the change of base formula exists because sometimes when you get into higher level math, you'll have to rewrite something in a form that makes sense or is more convenient to deal with. So change of base might be something that could be helpful to you. So you do need to know that the change of base formula exists. So here's how it works. You can rewrite it as a common log. So the log base a of b can also be written as the common log or log base 10 of b over common log of a. So if I were to estimate the value of log base 2 of 7, I can say that that is equal to log of 7 over the log of 2. And then if I get decimals, I can figure out what that decimal is. So I'll type in log of 7 over log of 2, and I see that's 2.807. Now, is that the same as log base 2 of 7? That's not 7. Yes, they're exactly the same. We call this we call this an identity. And so sometimes we use the change of base form, sometimes we use the log form. It just kind of depends on whatever's the most convenient for the situation. So here in some of your problems, you'll be forced to use a change of base formula. So if I were to solve this, I have the equation 3 to the x equals 15. Exponential form isn't great, so I'm going to rewrite it in log form. Log base 3 of 15 equals x. So I can solve for x by finding log base 3 of 15. Well, if I have a calculator that won't do that, I can say that this is log of 15 divided by the log of 3. And then I can approximate that to the nearest thousandth, which is 3 decimal places. So where's my calculator? Let's see. Log of 15 over log of 3, 2.465. Approximately 2.465. Now your homework will ask you to write it in this form and in this form, so you do need to know how to do both. So that concludes our lesson for today. Have fun with it, and I'll see you next time.